Okay, so let's draw this two-dimensional region, and then we'll talk about revolving it around the x-axis. So negative 2 times the square root of x plus 1. If we know the square root of x graph looks like this, then we know negative square root of x means all those y values that were going to happen just turn from positive to negative. So it should look like this. And then the 2 and the plus 1 just do some shifting. The plus 1 is a horizontal shift to the left, and the 2 just increases the scale. So the rough sketch should be something like this. So we're supposed to find the region that is bounded by this graph between 0, x equals 0 is over here, and x equals 3. So this two-dimensional region is getting revolved around the x-axis. So they say the disk method. So what we want to do is we want to envision a little disk being cut out of this volume that's going to happen. When you take this area, you revolve around the x-axis. It's like an ice cream cone with the pointy end cut at some point. So if we were to take a slice of that cone and look at it, it would look like this disk I just drew in 3 dimensions. So a slice would look like this. So that's 2 dimensions. If it's infinitely small, we're going to find the two-dimensional area, find a formula for the two-dimensional area, and then integrate it to bring it into 3 dimensions for the volume. So every slice is different. If you were to slice the cone here, slice the cone here, they're different sizes. It's bigger over on this side. Right? So we need a formula to help us find the area of that cone. So the radius is the key part of finding the area of the circle. So the radius depends on how far we are. So here's the slice. The radius is the distance from the x-axis to the end here. And that distance is found by plugging a value in for x into this curve. So this is your radius function. Okay. So the area of every one of these circles is pi r, which we said this is our radius, squared. And then we're going to say dx because we're going to find this integral with respect to x. So we want to integrate from 0 in the x to 3. It's pi times, here I'm going to square that now. Negative 2 squared is positive 4. Square root of x plus 1 is x plus 1 when it's squared. And then again, this is a two-dimensional area, pi r squared. When you integrate, you're going from the second to the third dimension there. You're taking that two-dimensional measurement, and as it changes over time, you're finding the volume through integration. So I'm just going to expand it algebraically. The tough stuff is done. Factor out that pi, and then we can factor out that 4 while we're at it. This is x plus 1. We can do that because they're both multiplying to everything else in the function. So a nice and easy integral now. Because it's just x squared over 2 plus x. We evaluate that from 0 to 3. So that's 9 over 2 plus 3. And then if you plug in 0, it's just going to be subtracted by 0 plus 0. So getting common denominators here, that's 6 over 2. So we got 15 over 2 times 4, 15, 30, 45. So that's 60 pi over 2, which is 30 pi. Let me just double check. Yep, okay, that's the correct answer, so I didn't mess anything up.